All right, so in this video, we are going to be talking about the last piece of implementing abstractions for now, which is a copy constructor and an equals operator. Up until this point, you should have a pretty good sense of how to design classes in general. You should have a pretty good sense of how to implement abstractions using placing things in private and public, have a sense of like what a header file is, what an implementation file, and how we're gonna be including them all in a header file. You should have a sense of new and delete and this, constructors, destructors, and the member functions, right? So I hope up until this point, it's starting to kind of make sense how these all get pieced together. And most of it is making, some immediate sense. Like once you kind of see it, you're like, oh yeah, I get it. So that's where the array goes, that's how it's allocated, etc. I think this is one of the areas that we see the most confusion is when we start writing functions that have multiple instances of the object. And it's very confusing and it takes some really deep thinking. So I'm going to try to explain it really carefully, but just know you might have to come back to this a couple different times and think through it to really get it. So first, let's motivate what a copy constructor is and why classes need copy constructors. The main reason is because when C++ has objects passed in by value, it requires C++ to make a deep copy, which requires it to have a copy constructor to use as, the instructions for how to make a deep copy of an object. So the basic idea is that, you're creating all of this like memory under the hood of your implementation, and a lot of that memory is pointers to heap allocated memory. And so in order to make a copy of that object, you need to copy all of that memory so that there's two instances of it. Otherwise, you'll basically have like two objects, but the objects point to the same memory. And so that would no longer be a copy, right? It would be referencing the same memory. So here you can see that we have a vector inside of main, and that vector is getting pushed. That vector is being passed into a function called f, and that function has that object passed by value, which means a copy is going to be made. So all that's happening is when that function is called, your copy constructor is called, and there's actually a couple ways to call it, but this is one way, which means that v2 is going to be constructed, and it's going to be constructed as a copy of v. And so v is the vector that was created in main, and v2 is going to be a copy of it in the local function. So on the next slide, I'm going to really go through how this copy constructor works and how it's written, but this is what it looks like. It's inside of the class, and it's just a constructor, so it uses as its function name the same name as the class itself. And then inside, the parameter of the constructor is another object of the same type. We pass that object in by reference because we don't want to make an unnecessary copy of it, even though we're ultimately making a copy of it inside, which is very confusing. But we want to pass in that object to this function by reference, but we are not going to be altering it, so we're going to keep it as a constant. So that's why you see the const there. And then we'll go over this code on the next slide, but this is basically what the copy constructor looks like. So again, remember, the copy constructor is called by default by C++ if you ever pass an object by value, and so you have to have a copy constructor associated with your class if you want to pass it in to functions by value. The copy constructor for the rvector class looks like this, and remember that these are our private member variables for the rvector class. So let's say that this is a R vector that we created, and let's say this is that v1 that, or did I call it v? Let me call it v. v, that's in the main. So this is the one that we're copying. So we're going to call this other. This is the original vector that we're copying. Let's say that it has some values. And so let's say that its size is 4, its capacity is 4. This is a vector that we would like to make a copy of. So other is this one right here that we're passing in and making a copy of. When we're inside of the copy constructor, the thing you need to remember is that it has not been constructed yet, right? If you are calling a constructor, it's because you are making an object that hasn't been constructed again. So we are making another object. So what happens here is these 3 lines are going to set the state of the object. So it's going to create an A that is associated with the object it's constructing, which is why you have a this. So A is going to have, it's going to be allocated on, and since we are using other's capacity is 4, so we're going to allocate 4 spots in memory for A. It's going to make size, and since it says that this is size, it's going to be the same as other size is 4, so this size is going to be 4. And then it's going to create a capacity, which is also matching other's capacity, which is 4. So this is the same thing you see in the default constructor, the parameterized constructor, right? You need to allocate the array and then set up any of its member variables. But then what's happening is that we need to copy what was in other. So we copied its member variables that are just the integers, but we haven't yet copied the array. So this code here is basically going to move 4 to A, move 3 to A, move 2, and then move 1. And so this code is running through the others values and copying them over to the current value. So the thing that's confusing is you have 2 objects. Inside of this function, you have the other object and you have the this object. So all of these are associated with this. It's the one that you're constructing. And I think the best way to kind of keep track of it is to remember that if it's a constructor, it's creating a new object. So you should have you know, the same code that's in your other constructor somewhere in your copy constructor. The only difference is instead of setting the values to some other parameters that are passed in, you're setting the values to the other object's exact values. Another thing I wanted to make sure to go over is that remember that this and other are 2 different types. This is a pointer to the current object, which is why you need the arrow, because the arrow is not only accessing the member variables, but also dereferencing them. And then, well, it's dereferencing the pointer to access the member variables. On the other hand, other is an object. It's not a pointer. So it is not like a pointer to the first private variable in the object. It's referencing the object itself. And so in that case, you only need to use the dot. And remember that you can't do other dot anywhere else. Like if you're in main, you can't access those private member variables because they're private, right? But because the constructor is written inside of the class itself, you can use the dot operator to access the member variables of either another object or this, you know, the arrows for the current object. So this is why it starts getting confusing, right? Because you have 2 objects that are, you know, accessible simultaneously. One is the current object, which is accessible via a pointer, and then the other one is the object that's getting passed in, which is the object itself and not a pointer. And yeah, so this is a copy constructor. So let's go over a little bit how this copy constructor works, and also introduce the operator equals, which is the next member function that we're going to talk about. Okay, so in main, you know that you can declare a vector an R vector using the default constructor, which is just going to set up a capacity 4. You know that you could instead create a parameterized constructor, maybe one that passes in the size and or the capacity, I mean, and then sets up the vector that way. So this would set up an R vector that's capacity 50. There isn't a parameterized constructor in the R vector class, but I think you could understand that there could be, right? So instead of putting 4 in all those spots, you would just put 50, the parameter that passes in. The copy constructor is a way to construct an R vector that is based off of a object that's already created. So we already made we already made V2. So the copy constructor, instead of calling the parameterized constructor with 50 and then copying manually, does it for you. So the copy constructor says, just make a new vector V3 that's exactly the same as V2. If we call a function f and we pass in the v1 vector into that function, and that function is receiving that object by value, we know that the copy constructor is automatically called. So here I'm calling it manually because I want a copy of v2. I'm going to call it v3. This is called automatically when you pass in an object by value. So that's all copy constructor, and that's all what we've already gone over. This last line here is the operator equals, which is different than the copy constructor, but very, very similar. So the difference here is that V2 is already constructed, right? I already made V2. But now I want to replace it with V1, just like when you make an int, right? So let's say you said int x equals 5, and then you're like, never mind, x equals 7. You're changing the value of that variable. We like to do that with our objects too. We just want to change them. And so the operator equals allows you to do that. But as you can imagine, it's much more complicated than just changing the value of an integer. And so how do you do that? Well, there's a public member function that you can write called operator equals. It overrides the equals operator for your object. And again, you have these same private member variables associated with your vector. So what's different? Well, you're going to see that all of the code looks very similar to the copy constructor. You're going to set up the current object to be equal to the other, and then you're going to do the copy. But the difference is that you already have the object has already been created. So when you called V2 here, V2, it already exists. And so you're going to have to, because you have to destruct anything that you created, and you're not going to call the destructor in this case because it doesn't go out of scope. You're going to have to destruct it yourself inside of the equals operator. And so before you start replacing A with this new array that you're copying from other, you have to delete what A used to point to. If you don't do that, you're going to have memory leaks, right? So it's an example of where all of the destruction doesn't necessarily happen in the destructor based off of the way you write your class. You also need to pay attention to destructing things in the equals operator. There's other operators where you'll need to destruct as well. Overwrite operators. And pushback was another case, right? In pushback, you had to delete the memory before you copied it over to the expansion. And so you have to really pay attention to memory mapping when you create these classes so that you can be careful to take care of all of your memory. And if we didn't do this in this equals operator, if we didn't delete the memory, we would have a memory leak. So when we ran valgrind, we would see that we allocated memory that was never destroyed. So that is a little bit about the copy constructor and the equals operator. As I said, I feel like they increase the level of complexity, one step up from everything else we talked about because of those two instantaneous objects that you're working with at one time. So it's a lot. as you start writing these classes, you're dealing with object-oriented programming, C++, which is sometimes not what you want. You have to allocate memory with new, you have to destruct it with delete, you have to deal with pointers. You have different instances of objects. There's all these different symbols. Many of them mean lots of different things. So make sure you take a lot of care to understand the topics from this week before you start building your first class, your first abstraction, because I think one of the reasons why people find the data structures class so difficult is because any gap in your knowledge, anything that you're like, oh yeah, I don't quite understand that, I'll figure that out later, it will be exposed when you write these codes. So you want to be really, really thorough with your understanding. Okay, good luck. That is it for now. I hope you all enjoy writing your first abstraction or implementing your first abstraction.